Hi folks, the purpose of this video is to give you a quick tutorial on how to use Google Spreadsheet to do some basic analysis on a position time graph. These are some of the data that was collected by my students, and what they've done is they've rolled down a cart on a ramp and they've recorded the position of the cart every 0.1 seconds. So I'm going to organize things a little bit first. So I'm going to select everything and I'm going to go to borders up here and I'm going to make it a complete border. I'm going to select these and I am going to press Control B or Command B on a Mac, and I'm just going to double click these so that they're taking a good amount of space. And once I have that, I'm going to select everything here and I'm going to align them horizontally, center them horizontally and vertically. And also every middle time, I am going to select these cells, and I can just select these as well and hold Control, or I believe Command on a Mac, and select these, and I'm going to change their color. I'm just going to change it to something nice and fun. Change it to a light purple. Once everything is nicely set up, what I'm going to do is I'm going to go and calculate the displacements. I know the displacement is change in position, and therefore I have to subtract this number from this number, or final position minus initial position, for every time interval where we measured the data. So in this case, I'm going to place it right in the middle. The reason why I'm doing this is because when we are calculating velocity, when we measure the initial position and the final position, and we are dividing that by the amount of time it took, it kind of measures the velocity right in the middle. It's not going to measure it's not going to be the calculation of the velocity at the end point or in the beginning point or this initial point. It's going to be right in the center. That's why we're doing it this way. So what I'm going to do here is I'm going to press equal and I'm going to select my final position. I'm going to subtract initial position, or subtract initial position from the final position, and I'm going to press enter. Once I have this, I'm just going to Control C for copying, and I'm going to go here, 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 and here, and I'm going to paste. And what it will do is it will paste the formula accordingly. So if I double click this, you can see that it's this and this. This is a subtraction of this and this, and this is the subtraction of the final position here from the or initial position from the final position here. Okay, so after checking and making sure that all the formulas are nicely placed, I'm going to start calculating the velocity. The velocity is displacement, or change in position over time. So I'm going to press equal, and I'm going to take this displacement and I'm going to divide it by the change in time. I know that the time was always 0.1 seconds, so I can just put that, or I can just put brackets. Change in time was from 0.1 or 0 to 0.1. So then I press enter and it will calculate the velocity. And I'm going to do the exact same thing. I'm going to right click and copy, and this time I'm going to do it differently. I'm going to select all the purple cells, and I'm going to right click, I'm going to paste, and I'm going to paste formula only. Oh, this time it didn't paste in all the cells, so I'm just going to copy and go to these cells, and I'm going to Control V for paste, and it will paste the formula. And in this case, because we're dividing by 0.1, that's exactly the same thing as multiplying by 10, and you can see that the decimal places have moved one to the right in each case, and that's exactly what we want. Alright, it's time to find the acceleration. I know that acceleration is change in velocity over change in time. In this case, it's the average acceleration between each set of velocities. So to calculate this, what I'm going to do is I know that this is my final velocity and this is initial velocity from time 0.05 to 0.15. So I'm going to click here, I'm going to say equals, and I'm going to open my brackets, and I'm going to do this number minus this number, close brackets, and I'm going to divide it by this number minus this number. Or you can just do 0.1 because you know that all the velocities are the same. And I get this lovely value here. And then I'm going to copy, and I am going to select this cell, this cell, this cell. And I'm going to try this again and see if it works. I'm going to go paste formula only. And this time it worked nicely. I think last time I misselected something. And you can see that the acceleration is 133, 140, 148, and 128. You can see the number isn't changing too much. There is a little bit of uncertainty and errors, which completely makes sense, but our highest number was 133. It is approximately, let's say on average, about 100 and a little bit below 140 on average. You can see that the acceleration is decreasing, and if we continue these numbers, we would actually see that the acceleration will probably get to 0, because what's happening when the cart is going down the ramp, it's actually accelerating, but later on it's going to hit the counter and it's going to go straight, and as it's going straight, it's no longer accelerating because gravity isn't helping it to actually accelerate, and therefore the acceleration will actually decrease, and you get a constant velocity. So this should reduce to 0 if you continue your data, and if you had a cart that's going down the ramp and then going in a straight line afterwards. But in this case, this is approximately where the ramp was, and the data looks very nice. Okay, so what we're going to do now is we are going to plot the position time graph. So I'm going to select these two set of data, which is position and time. I'm going to go to insert, I'm going to go to charts, and I get this lovely little thing set up in here, and I'm going to select the chart type, and I'm going to go scatter. And once I have this, my series here, it says that it's position. The series is always the y-axis, and it is position that I want. And the x-axis is time, and that's exactly what I want, so this is fantastic. And it's already labeled everything for me. This is saying that it's position in centimeters, and it's saying that this is time in seconds, and we can see that it's a very nice curve. Now I can also go to customize, and I can select series, and I can change the point size if I wanted to. You can change it to any values. I'm going to change it to 5. The color I'm going to change, I like red. You can change it to anything you want. And I'm actually going to add a trend line. And in this case, I can see that my data kind of looks like a quadratic. So I'm going to change this to polynomial, and you can see that the data fits very, very, very nicely. And I'm going to actually label everything using equation, and that brings the equation right here. So that's the equation of the line. And I'm going to show the r squared value, which in layman's term just says how close are the dots to the line of best fit. And r squared is actually 1. It's actually perfect, which means that the data were actually amazing. So this is good, and I'm going to leave this to the side here for now, and we're going to, actually I'm going to make it a little bit smaller. Again, everything is nicely graphed. You can keep this here, or you can remove it. Usually in reports, I have students write it in down here as figure 1, position versus time, but I'm going to keep it up here for now. And the next thing we're going to do is we're going to plot the velocity time graph. The idea is the same. We're going to select the velocity, and we're going to select the time here. To select two different things, I'm using Control on a Windows computer, and if you're using Mac, I believe it's the command that you hold, or it might be Control. I don't quite remember at the moment, but try one of the two. And then you're going to do the same thing. You're going to go to Insert, you're going to go to Charts, and see, this time now it's giving me something a little off. So it's giving me a bar graph. So I'm actually going to go to chart style, or actually I'm going to go to setup. For chart type, I'm going to select it, and I'm going to go scroll all the way down and select scattered. See, it's a beautiful linear line. This is fantastic, and everything is labeled for me nicely because I have things labeled here. So this is basically, this label is coming from here and this label is coming from here. I'm going to move this. I'm going to make it a little bit smaller just so that it's approximately the same size as the other graph. And then I'm going to do the same thing. I'm going to go to customize. I'm going to go to series. I'm going to change the size, and should I change the color? I'm going to change the color to, let's do purple on this one. And I'm going to change the sizes to 5. A little bit big right now. And I'm going to do the same thing. We're going to do a trend line. And you can see that automatically it picks linear as the first thing. And in this case, we do have a linear line. I'm going to do a show r squared. You can see all the dots are extremely close to the line of best fit. So we get r squared value of 1. And we can also label using equation, and that way we can see the equation of our line as well. Everything else looks good at the moment, so we're going to go ahead and plot the acceleration time graph as well. Okay, for acceleration time graph, I need to pick this set of cells and this set of cells, and I'm going to go insert chart, very similar idea, and see, I can see now that I have the data all scattered around here, and this is fine. We got series, which is acceleration is centimeters per second, time is second. You can see that Google spreadsheet at the moment, at the time of this recording, does not have the capability of allowing us to write this as centimeters per second squared properly. Some people use Shift 6 in order to write it, but that's not the best way to write it either. But yeah, Excel you can get around with different ways of writing it. However, at the moment, Google Spreadsheet hasn't done this, which is pretty weird because Google Spreadsheet has been around for a very long time. This is pretty typical for a physics or math course. So anyways, it's something that hopefully Google Spreadsheet will bring out later. But I have time, I have acceleration, everything looks good. I'm actually going to select the data. If I select any of the data, it will actually bring me right into the series, which is customizing the series section. I'm just going to go set up just to make sure it's a scatter plot. It's not at the moment. I am going to change that to scatter. That should be the first thing you always do. And then I'll select one of the data points and I'll go right into series, and I can do a trend line. Linear is good in this case, and show r squared. R squared is much less this time. The data points are very far away from the line of best fit, but that's fine. It's not an issue at all. And we can see that we have a pretty consistent value of acceleration through the time, which is absolutely fantastic. So I'm going to make this slightly smaller, and I'm actually going to scroll down and bring this down as well. So now I have all my set of data. Make this slightly bigger so that it's the same size as the one above. And in terms of colors, I can keep it the same. I can also do, let's do, this is the line of best fit. And actually, yeah, if I double click as well, I get to the color. I'm just going to change the colors to this. Actually, it's a little bit harder to see. I'll go back and change it to, let's change it to blue. Okay, this is fine now. I have my 3 graphs. Let's talk about analyzing things a little bit more. Alright, let's say that there was a question asking us to calculate the displacement from velocity time graph. We know that, that displacement can be found from the area underneath a velocity time graph. So in this case, we can find the area under this. This is an approximate shape of a triangle. So I'm going to write this displacement analysis, and I'm going to save VT graph. And let's say we were to do it from displacement analysis from 0 to 0.4 seconds. So that's from here to here. And if I were to find the area underneath this graph, we can see that this distance here is approximately, if this was 10, this is approximately 4. So I would have to take this little triangle here, or big triangle, and then add the area here, which is kind of like a rectangle. So to do this, this is equal to, if this whole thing is 60 and this is 4, we're left with 56. That's the height of my triangle. I'm going to multiply that by the base, which is 0.4. And I'm going to divide it by 2. Because it's a triangle, base times height divided by 2. And I'm going to add that to this area over here, the smaller one. I'm assuming that this is 4 and this is 0.4. So simply 4 times 0.4 will give me an approximate area underneath that graph. And that gives me 12.8. And we can compare that to the position time graph. And we actually have, and this point is right on the line, or you can actually go at 0.4 and look at the position and see what it corresponds to. I'm just going to go up and see what it does correspond to. 12.87. So equals to 12.87. You can see that we were extremely close to the right answer. This is the answer that we got based on our analysis, and this is a more accurate answer. So what I'm going to do then is do a percentage error analysis, and that is equal to the absolute value of this number subtracted by that number, or one of them subtracted by the other. So this minus this. Actually, I have to do this in brackets, 2 sets of brackets. And I have to divide this by the theoretical value. In this case, well, it'll be the value which is coming from the position time graph. So I'm going to select this, and I'm going to press enter, and I'm going to go here, go to format number, and I'm going to change it to a percentage, and this is 0.54%. That's very, very precise. Usually if you're within 5 to 10%, you have a good set of, you have done a very good job with your experiments, and here we have. So this is fantastic. Now, let's say you were asked to do an analysis where you had to figure out the velocity or instantaneous velocity from position time graph. So I'm going to highlight this actually as, I'm going to border this. I'm just going to border it around like this. And just for the numbers, I'm just going to align it or center it vertically and horizontally. And here I'm going to do velocity analysis, and I'm going to do it, and I want the instantaneous velocity, so I'm going to do it at, it doesn't matter which time you're going to do it at, I'm going to do it at 0. Let's say 3 seconds. And we're going to do it from a position time graph, and we're going to do it, and we're going to compare it to the answer from the velocity time graph. So one other thing that I have forgotten in all my values here, I'm going to go back to it. I haven't indicated a direction, so I'm actually going to go here and write forward. And actually my graphs are not really updated really nicely, so actually I'm going to double click here, and I'm going to write forward in all of these because the cart was moving forward, and at the moment I'm calculating velocities. However, I don't have a unit, or I don't have a direction, and that's not a good thing. So anyways, now it's correct, and you can go back to your table and add those as well if you want. I'm gonna do that actually. This is forward, this is forward, and finally this is forward. And once you have that, you can double click all these to kind of make the cells as small as they can get. Okay, back to it. We want to do an analysis here, and we want the velocity at 0.3 seconds. If we're doing that from a position time graph, then we need to draw a tangent at 0.3 seconds and then calculate the slope based on 2 points on the tangent. So what I'm going to do now is I'm going to draw a tangent on Google spreadsheet is kind of challenging, but what I can do is I can go to insert and I can go to drawing, and I know that my slope is going to be going it's a positive slope, so I know it's going to look something like this. So I'm just going to save and close, and I can see that it brought it here. I'm just going to bring it up here, and I'm going to place it at 0.3, and I'm actually going to just adjust it slightly so that it represents the slope there. This is actually pretty good now, so I'll keep it right here. This is pretty good. It indicates it's showing the slope pretty well. And what I want to do also is I want to pick 2 points on the graph. One of them is not too hard. I can choose one of the points here, and I can choose the other point right at 0.3. So let's do that. So at 0.3, my position is approximately 7.5. So yeah, 7.5. And so my delta y here is, so PT graph, my delta y is 7.5 minus 0, because this point over here, the y value is 0. And I'm going to divide that by delta x, and my delta x is from 0.3 to this point, so 0.3 minus, and this one I'm going to approximate as if this is 0.1, this is 0.2, this is 0.15, so I'm going to go 0.14, and that's my delta x, or delta t in this case. So I'm going to divide, I'm going to get this value. I have way too many significant figures, so I'm just going to reduce it a little bit. I'm not really showing you significant figures in this example, so that's why I'm not really I'm not focusing on that. This is again just a tutorial on some of the techniques in Google spreadsheet. From velocity time graph, if I go to 0.3 seconds, and if I go up, and if I point my cursor all the way to the left, I can see that it's somewhere here. If that's 50, that's approximately 46, 47, I believe. I'm going to try it again. Or actually, you know what I can do? I can go insert, and I can go to drawing. I can draw a straight line. If you hold shift, it draws it straight. I'm going to go here, and then I'm going to move this up at 0.3. That way I can see exactly where it's hitting. The other thing you can do is you can double click on this vertical axis, and I believe there is a spot where you can, maybe it's not here in vertical axis, but it's on the grid lines. Grid lines, vertical axis. I'm going to add minor, and I'm going to go every minor grid lines. 1, 2 gives you more, so I'm going to go 10. and then that way I can actually see things a lot better. So now I can see that this 0.3, I'm just going to zoom into my graph, and I'm going to go down, and I can see this is 40, 42, 44, approximately 46. I'm going to make this smaller, so approximately 46 here. Percentage error is calculated the same way, so I'm going to go percentage error, and to calculate it I'm going to do my the absolute value. So that just means that it's taking the positive value, and I'm going to subtract these two values from each other, and I'm going to divide it by the accepted value. In this case, the accepted value comes from the velocity time graph because it's the velocity, and that gives, and I'm going to go to numbers, format numbers, format numbers, and I'm going to go to percent, and it's 1.9%, again less than 5%. This is fantastic. I'm going to select the whole thing, and I'm going to box it, and this is my analysis. So you can also do the same thing. You can find change of velocity from the acceleration time graph. You can find the instantaneous acceleration from velocity time graph. You have all these options, and you can do your analysis. I'm just going to also center these so it just looks better. And again, I haven't included units in some of the places. This is again more for you learning how to use spreadsheet rather than proper tutorial with proper number of significant figures. Okay, I hope that this video was helpful for you folks, and I hope that it helps you in the future as well.